Dhavaneshwara, sir. Dhavaneshwara, hello. Dhavaneshwara, hello. Hello.
Sir, Butchra sir. Okay. See, let us continue our actual topic, what we have stopped in the earlier class. First, let me share my screen to you. Please let me know how is my screen is visible to everyone or not, right? Students, is my screen is visible?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, okay.
Yes, sir.
Please, all of you, stop your videos for some time. See, no problem. We will take our own time. We'll continue it in for 1 hour also. Okay. So you need not worry about the syllabus. Definitely, I will try to complete the syllabus in time. Right. I think we have stopped the session, the yesterday session at this particular problem. Right. Is it not? Roll number 213. Is it not?
Yes, sir.
Have you attended yesterday's session?
Yes, sir.
Okay. See, the problem here is write the mathematical expression for the given symbol. That means, see, vice versa is possible. If we have given a mathematical representation, then it is possible to represent the same function in graphical representation. So suppose if you have given a graphical representation, it is also possible to obtain mathematical function from the graphical representation, right? Now, let me explain how this can be possible, right? Please don't try to write down on the white page or PPT, okay? See, let me know, is it visible? Is it visible? I'm drawing a line, straight line here. Is it visible to everyone?
Yes, sir.
Okay, okay. See, just now we have discussed that write the mathematical expression for the given symbol. So forget about this one. F of t is equal to 1 or 0 less than t less than 2, right? Now see here. Now see here. So the problem is like this. The problem is like this. Okay. So you have been given a graphical representation like this. This is the problem. See, forget about the solution. I will explain how this f of t is equal to 1 will comes from this graphical representation. Just forget about this entire one. So write the mathematical expression for the given symbol. Symbol is this one. Symbol is this one. So here on y-axis, I am considering f of t. On y-axis, I am considering f of t. See, just you carefully watch what I am going to write down on this and how this will be looks like. So I am considering 2 and I am defining. Two here. See, this is a problematic subject, so definitely we must have some patience. Okay, to understand the how problem and to analyze the solution also, we must have some patience, right? So here, is everyone are there? Is it visible what I'm doing?
Yes, sir.
Okay, okay, thank you, thank you.
Yes.
Please have some patience, right? Now see here. Now in the problem itself, he has given that a graphical representation. Graphical representation like this. Okay, right. So f of t, we shall take this f of t on y axis. And small t on x axis. Okay, I think somebody has raised their hand. Okay, please unmute your mic and speak. Please unmute your mic and speak. I think this is not working. 202.
Nothing, sir.
Okay.
By mistake it came. Sorry.
Okay, okay,
Please carry on. Yeah.
okay. Okay, now see here. See, here we are considering y of t on y axis. See, sometimes I'm using the word y of t, but this is function that maybe, see, we don't know whether it is an input function or whether it is an output function. Sometimes I'm using the word, see, generally y of t is an output function. Okay, we are not going to consider this. Okay, let me consider either f of t or x of t. Is everyone, please tell me, is my screen is visible? I'm sharing my whiteboard.
Yes, sir. Visible.
Okay,
Yes,
okay,
sir.
thank you. Okay. So here on y-axis I am considering f of t, and on x-axis I am considering time. Okay. Now here the problem is he has defined a function that is defined from 0 to 2. 0 to 2. Okay. So the problem is this: write down the mathematical expression for the signal which is shown in the figure. Now this is the problem. Now our solution is very, very important. So if you have given this type of graphical representations and you are asked to write down the mathematical expression, means first of all, please see the graphical representation clearly. So here the interval is given. The interval is clearly shown, that is 0 to 2. So in between 0 to 2, the signal is present, and that's having the amplitude is equal to 1. And for remaining values of time, that means minus infinity to 0 and 2 to infinity, you do not have any amplitude or you do not have any information, right? So that is why I am considering a function f of t. This is the mathematical, I am writing the mathematical representation for the graphical representation, which is as shown below. So f of t is equal to 1 for f of t is equal to 1 for t, not t here. Please do remember. Okay. So f of t is equal to 1 f of t is equal to 1 for t, sorry, 0 less than 2, t less than 2. Now this is the case. Now please all of you look at this. F of t is equal to 1 for f of t is equal to 1 for 0 less than t less than 2. That means from 0 to 2, f of t is equal to 1. What about the remaining values of time? What about the remaining values of time? It is equal to 0. Now see here. So which is equal to 0 for otherwise. Otherwise, that means which is equal to 0 for otherwise. Now clearly see this one. So f of t is equal to 1 for 0 less than t less than 2, and which is equal to 0 otherwise. So here you do not include for. Otherwise means obviously, okay, the times which have been not included in the previous interval. So minus infinity to 0, which is not included, and from 2 to infinity, which is also not included. Okay. Now this is the mathematical expression. Again, we are going to represent the same mathematical expression in terms of unit step signals. Okay. Now let us see how this can be represented with the help of unit step signals. Okay, is it visible? Please let me Let me know how many of you have visible this one.
Yes, sir.
Okay. Do you understand what I'm going to explain? Do you understand what I'm going to explain? So f of t, this is the graphical representation you have been given in your examination question paper. And for this graphical representation, you are asked to write down the mathematical expression. Mathematical expression that is given by f of t is equal to 1 during this particular interval, and which is equal to 0 for this one. That means otherwise. So otherwise includes minus infinity to 0 and 2 to infinity. So only in between 0 and 2 you will have that one value, right? Okay. Now let us see how this same graphical representation, okay, is going to be expressed in terms of unit step functions. Now, can anyone tell me the definition of unit step signal? Can anyone tell me the definition of unit step signal? Anyone? 221?
U of t equal to 1, I think.
Okay. Say the unit step signal is clearly denoted. Okay, u of t clearly denoted with the u of t. Sometimes I am using f of t also, but in that particular case, you need to consider f of t is equal to u of t. So here you are asked to express the same mathematical expression in terms of unit step signals. That means u of t is equal to 1, which is defined from 0 to infinity. Which is defined from 0 to infinity. Now see here, u of t is equal to 1 from 0 to infinity. Similarly, now see here. So this magnitude f of t is having magnitude is equal to 1 in between 0 and 2. Okay. So from 0 to infinity, this value is also equal to 1. So if you consider next, if you consider the delayed unit step signal, which is delayed by 2 units. Now what happens if the same unit step signal is delayed by 2 units? Means obviously you will get u of t minus 2. U of t minus 2. Now this signal will start from 2 onwards. Why? Because the basic u of t signal is delayed by. So whenever I'm using minus symbol means obviously that one is delayed. Okay. Delayed signal, which will starts from 2 onwards. So from 2 to infinity, this value is equal to 1. Now from 0 to infinity, this value is equal to 1. Now again, the same mathematical expression f of t can be expressed in terms of unit step signals in such a way that you need to consider the difference between u of t minus u of t minus 2. Now let me explain how this will comes. Now u of t, basically this u of t signal, this u of t signal is defined from 0 to infinity, and that value is equal to 1. And this u of t minus 2 signal is defined from 2 to infinity. Suppose if you take the difference between u of t and u of t minus 2, what you will get? So u of t at a time t is equal to 0, this value or amplitude of u of t is equal to 1, and the amplitude of u of t minus 2 is equal to 0. So 1 minus 0, what you will get? 1 minus 0, what you will get? You will get 1. That means at t is equal to 0, the amplitude of f of t is equal to 1. Now consider another case. So in between 0 and 2, I am taking one more time value, that is t is equal to 1. So at t is equal to 1 also, you will have u of t is equal to 1 and u of t minus 2 is equal to 0. So 1 minus 0. Again you will get at t is equal to 1 also, at t is equal to 1 also, f of t is equal to 1. Now please carefully see that at time t is equal to 0, the value or the amplitude of u of t is equal to 1 and the amplitude of u of t minus 2 is also equal to 1. So 1 minus 1 is equal to 0. That means the slope becomes 0. Now see here. Now see here. So up to 0 to 2. So that's why I have not included the greater than or equal to or less than or equal to. Why? Because at the time t is equal to 0, the slope changes, and time t is equal to 2 also, again the slope changes. So whenever the slope is going to be changed, means obviously we should not include this negative, equal to symbol. So in between 0 and 2 only, the amplitude of f of t is equal to 1. Understand? Is everything is okay? Is everything is clear? Can anyone respond?
Sir.
Please unmute your mic. Is everyone?
Yes, sir.
Okay. If you are having a small doubt, you
Sir.
can raise your doubt also. Okay, I will explain. So basically this graphical representation has been given in your question paper, and you are asked to write down this mathematical representation. Sometimes you are also asked to write down the same expression in terms of unit step signals. Okay. Now this is about the problem what we have discussed. What we have discussed in the last class. Okay. So let me continue the point where we have stopped. Now see here. Now see here. So I think it is very clear. So write down the mathematical expression for the given symbol. Symbol is nothing but graphical representation. So I think the doubt which is comes to your mind that why SAR has not included less than or equal to or greater than or equal to symbols here. Why? Because at 0, t is equal to 0 and at t is equal to 2, the slope changes 1 to 0. Slope 1 nunchi 0 change avutundandi. So that is why we have not included that less than or equal to or greater than or equal to symbols. Okay, and which is equal to 0 elsewhere. Otherwise, sometimes you are in some textbooks you will find that word also, otherwise. Otherwise means minus infinity to 0 and 2 to infinity. So this is the function f of t is equal to u of t minus u of t minus 2. Okay. Now the another type of continuous time signal is triangular function. See, these are all types of signals, types of continuous time signals. Okay, everywhere in signals and systems you are going to find out the same signal. So sometimes in your problem I will not give you the mathematical representation, or I won't mention the graphical representation also. Consider an input as a triangular function. So consider, whenever I am using the word consider an input function as a triangular function or sinusoidal function or unit step signal or unit ramp function, means obviously you need to remember the basic definitions of those signals. Then only it is possible to solve the problems in signals and systems. Okay, otherwise it is very difficult to solve the problems without remembering the basic definition. So that's why I'm going to explain each and every input functions that we are using regularly in signals and systems. So here I'm using triangular function. Is my screen is visible? Is my screen is visible?
Yes, sir.
Okay, I am displaying triangular function here. Triangular function here. Now see here. Again, f of t. So this is an input function which is equal to 1 minus mod t by a for mod t less than or equal to a, and which is equal to 0 when mod t greater than a. This is the standard triangular function. So see here, from 0 to a you will have a ramp function, and from minus a to 0 you will have one more ramp function here. Now how this function will comes? This is also very important. Do you know how to write the straight line equation which is passing through 2 points? How to write, or how do you obtain the straight line equation which is passing through 2 points? Now let me explain. Now see here. So I am splitting this entire function f of t into 2 parts. So here this is f of t and this is minus a, and this is 0, and this is 1. Okay. Now please observe it very carefully. Now I am going to explain how this mathematical expression is written from the graphical representation of a triangular function. Now this is a straight line which combines minus a and 1. Now what is the point here? So here on x-axis x coordinate is there minus a comma 0. On y-axis you will have 0 comma 1. Now you will have 2 points. So first one is minus a comma 0, minus a comma 0, and the second one is 0 comma 1, 0 comma 1. Okay. Now how do you write down the line expression when it is passing through these 2 points? Y minus y1 is equal to m is nothing but here slope multiplied by x minus x1. Now carefully see this. So where m is equal to y2 minus y1 divided by x2 minus x1. Clear? So how do you determine the slope of this one? So now this is minus a is x1 and 0 is x2. Sorry, x1 y1, x2 y2. Okay. So y2, what is y2 here? What is y2? 1 minus 0. y2 is 1 and y1 is 0. Similarly, 0 minus of minus 0 minus of minus a, that you will get as a. So m is equal to 1 by a. Okay. Now what is y coordinate? That means, so here y is nothing but, what is the function we have considered on y axis? We have considered f of t on y axis minus, what is y1 here? y1 is equal to 0, which is equal to, what is the slope here? 1 by a. X minus, what is x1 here? So here sorry, on x-axis I am considering time t minus, what is x1? What is x1? What is x1 here?
minus a, sir.
Minus of minus x minus x1, x minus x1. So I think you will get this one, this function. Is it clear? Is it clear?
Yes, sir. Yes, sir.
223, 210, 19 series. Is it clear? So f of t
Yes,
okay, okay. Y minus y1 means on y axis we have considered f of t and y1 is 0. Y1 is 0. Please don't. 219, 18 series 219. Already I have warned so many times. Please don't write on the whiteboard, or please don't write on the PPT. So f of t. So on y axis I have taken f of t minus, what is y1 here? Y1 coordinate is 0. So 0 minus is so equal to m into, m is equal to 1 by a multiplied by, so here x is equal to t. On x axis I am considering time t plus a. Now please let us solve this one. F of t is equal to 1 plus t by 1 plus t by a. Is it not? 1
Yes,
plus
sir.
f of t is equal to 1 plus t by a. Is it clear?
Yes, sir.
Okay. This is the mathematical expression which is obtained by considering only one ramp function. But in the triangular function, you will have one more ramp function that is from 0 to a. So similarly, you can solve this one. Okay. In that particular case, when we consider the ramp function, which is this is decaying ramp function. Okay, this is rising ramp function and this is decaying ramp function. If you consider that one, obviously what you will get? What you will get? So you will get 1 minus t by a. But you need to combine these two functions when we are going to define triangular function. So you will have two mathematical expressions. So first one is 1 plus t by a, which is defined from minus a to 0, and you will get 1 minus t by a, which is defined from 0 to a. So in between these two minus a and a points, you will have triangular function, and for the remaining values of time you don't have. So see here f of t is equal to 1 minus mod t by a, where mod t you can take it as plus or minus t. Suppose if you consider this as minus t is less than or equal to a, means obviously t must be greater than or equal to minus a. Similarly, you can take minus symbol also. So this is the standard triangular function mathematical expression. Okay, now in this way you are going to analyze all the types of signals. Okay, first let me erase all the Is it clear? Is anyone having any doubts regarding this derivations of mathematical expressions from the graphical representations? 19 series 210. Respond. 19 series 210. Are you there?
Yes, sir. Yes, sir. Yes, sir.
What is your name?
Epsiba, sir.
Okay, Epsiba. So are you clear?
Yes, sir.
Okay, next we are going to see one more functions, that is other functions. See, so many continuous time functions are available. Okay, so many continuous time signals are available, or continuous time functions are available. So in that particular case, signal function is also there, sync function is also there. See, just I have defined those functions. Why? Because these functions are not regularly using in our signal systems. Rarely we are using this type of functions. But whenever we are using that type of functions, obviously you must remember the basic definitions. Now see here, signum function. So signum function is defined as mathematical. This is the mathematical. So these are the mathematical expressions. The unit signum function is defined by, this can be denoted with the SGN of t, signum of t. You must remember the standard notations or standard denotions for the signals. Okay, U of t stands for unit step signal, R of t stands for ramp signal. Okay, so similarly f of t, sometimes I'm using f of t, and I will give you the information that f of t is, consider f of t is a ramp signal, or consider f of t is a unit parabolic signal, or consider f of t is a unit step signal. Okay, don't think that always you will get the known functions. So sometimes I'm using another function, and I will show you the direction that f of t is nothing but a ramp function or unit step signal or whatever it may be. Okay, so here signum of t is the standard notation for the signum function, which is defined, or which is divided into again two parts. When t is greater than 0 and which is equal to 1, and t less than 0 which is equal to -1. Okay, can anyone tell me why in this particular case 0 is not included?
When t equal to 0, it is 0, sir. I mean, sin of t equal to 0 అవుతుంది సార్. అంటే t equal to 0 తీసుకున్నాం.
Yes, but you need to define it in another way. Okay, so at t is equal to 0, what is signum of t? That's value is equal to 1.
0.
At t is equal to 0, see, t greater than 0, signum of t value is equal to 1,
Yes, sir.
and t less than 0, signum of t value is equal to -1. But in
At t
between t
equal to
greater
0.
than 0, t less than 0, t is not equal to 0 has not been included. Why? Because at t is equal to 0, the slope changes. Slope changes. Is it clear? So 1 minus 1, 0. So that is why t is equal to 0 has not been included. If you incorporate t is equal to 0 in this one, obviously you shall write down here signum of t is equal to, see here again I am writing by including t is equal to 0. So sgn of t is equal to 1 for t greater than 0, and which is equal to 0 for t is equal to 0. Next, which is equal to -1 for t less than 0. Is it clear? Is it clear? Everyone. So if you want to incorporate t is equal to 0, now this is the mathematical expression for the signum of t. So signum of, if you do not want to include t is equal to 0, means obviously this is the mathematical representation for the signum of t. Similarly, you can consider the same function may be expressed in terms of unit step signal. So that is the mathematical representation. Signum of t is equal to -1 plus 2 into u of t. So similarly, sinc function is also available. See, the amplitude is more at t is equal to 0, and amplitude is going to be decreased when t approaches to infinity. So that is the signum of sinc function. So sinc function may be defined as from -infinity to +infinity sin t by small t. So whenever the function of this type, you can directly consider that function as a sinc function. Okay, next, one more function is also available, that is a Gaussian function. So Gaussian function is a very rarely using function, but sometimes you are asked to tell me any doubts? Okay, no doubts. Gaussian function. So this is the general waveform shape of the Gaussian function. So the mathematical expression for the Gaussian function is e power minus a into t square from -infinity to +infinity. Whether, okay, I think in the chat box some people are having some doubts. Okay, when t is equal to 0, the value is 0. Okay, so some of your friends raising a doubt that, sir, when t is equal to 0, how you are defining the slope? Okay, let me explain how I'm going to define the slope. Okay, now see here. Now this is the case. New shade. See, now I'm going to explain why I'm using the word slope. Okay, slope changes. Now this is the case. Okay, Now this is the case. Now I am trying to explain the signum of t here. Okay. Now see here. So it is 1. It is -1. -1. See, is my screen is visible? Is my screen is visible?
Yes, sir.
Okay. See, now I am going to explain why I am using the word slope. So here, this is a signum of t function. So which is defined from t greater than 0, that's value is equal to 1, and t less than 0, that's value is equal to -1. But what about time t is equal to 0? First, let me know, is it continuous time signal or discrete? The signum of t.
Continuous.
Continuous. So that means that signal is continuously defined from -infinity to 0. Okay. So if I mark it as t is equal to, so at t, definitely at t is equal to 0, the slope, why I am using the word slope changes. So up to here, the slope is equal to 1. So don't consider that always the slope is for the ramp functions. Don't consider that always the slope is for only the ramp function. Slope is also for the remaining functions also, right? Okay, don't consider always this type of functions are existing. So here, why I am using the word slope changes means, obviously here the amplitude becomes 0. So 0. Please see here. Now see here. Now tell me, is it continuous? So this thing he does not mention in the textbooks. Okay. Now see the shape of the line. So at t is equal to 0, obviously it will becomes horizontal. Okay. If you want, you can use it in angle also, 90 degrees or whatever it may be. You can take it as whatever it may be. So that is why I'm using the word slope is equal to 0. That means it changes its path, the line. So it changes its path to -1. So obviously it can be treated as 0. Okay. Some of your friends asked that, sir, at time t is equal to 0, the amplitude is also equal to 0. So obviously you can consider that one also. Okay. So at time t is equal to 0. Now what is the amplitude here? So at time t is equal to 0 means obviously this will be, now please see here. So this is the combination of, sorry. So this is the combination of two functions. This is the combination of two functions. One is this one. One is this one, that is unit step signal u of t. This is u of t signal, and this is one more signal that is also equal to u of minus t. Please do remember. So if you combine these two waveforms, obviously you will get this one. So if you are getting some confusion regarding the slope of this signum function t, okay, anyone? If you are confusing, if you are thinking that we are getting some confusion, if you are using the slope means, obviously you can consider this also. So in one function you can use the unit step function, which is defined from 0 to infinity. That's value is equal to 1. And in another case, u of minus t. Okay, obviously that's value is also equal to -1 from -infinity to 0. Later, we shall discuss about the time reversal. U of minus t is nothing but the time reversal operation. Okay, if you combine these two waveforms, so this is also at time t is equal to 0. Obviously, the value is also equal to 0, and this function, for this function also at time t is equal to 0. Obviously, this is also equal to 0. If you combine this one, obviously you will be able to get this one, right? Is it clear? Is it clear? Okay. One more question is there, sir. At time t is equal to 0, slope will be infinity. See, that is why. So if you are getting some confusion, means obviously just forget about that one slope concept. Okay, if you are not able to understand the concept of slope, obviously please just forget about that one. You please try to remember these two types of signals. So first one is this one. First one is this one, second one is this one. So if you combine these two functions, so that is why already in the PowerPoint presentation, I have given you the mathematical expression in terms of unit step signals. Now please look at this one. See here. So that can be expressed in terms of unit step signals as -1 plus 2 into u of t. Okay. See, if you are getting some confusion, means obviously I will give you the another solution also. Please don't get confused. Okay, this thing is very, very clear. Signum function can be considered as shown in the figure, or it can also be expressed in terms of unit step signals also. And similarly, next one is sinc function. So sinc function is, so gradually the amplitude of the waveform is going to be reduced when it approaches to minus infinity and when it approaches to plus infinity. Okay. Next, Gaussian function. This is also very rarely used function, but you please remember this one also. The Gaussian function is expressed with the use of mathematical expression GA of t is equal to e power minus at square. Sir, why I am using or why these notations? Is it possible to remember those notations? So obviously it is very, very easy to remember the notations once if you completed that particular subject, signals and systems. Why? Because whenever we are using or whenever we are going to solve a problems, obviously in all the problems you are going to face the same notations. Okay, so if we keep on exercising the notations, obviously it is very easy to remember also. Now please see here, next one is real exponential signal. So here real exponential signal mathematical expression is given as x of t is equal to, see here, now see here, x of t is equal to a into e power at. So this is the basic definition of real exponential signal. A real exponential signal. So here I have given three waveforms. The first one is a DC signal, and second one is exponentially growing signal, exponentially decaying signal. So the case 2 function is exponentially growing. This is also, you can call it as exponentially increasing or rising signal, exponentially decaying signal. Okay, so just you forget about capital A. This is just the multiplication factor. See, exponential signal is, now I'm going to share my whiteboard also. Please look at this. Now with this we are going to complete our okay, types of signals. See, just forget about this capital A. Capital A is nothing but only the multiplication factor, and you should remember only e power at. So what is this A? So this A is nothing but a constant, and this depends on the value of A here. Now please see here. So if A is equal to 0, small a, if small a is equal to 0, what you will get? X of t. If a is equal to 0, what you will get? X of t is equal
Yes, sir.
to? Yes.
Capital
If,
A.
yes. If small a is equal to 0, 0 into anything 0, e power 0 is equal to 1, and you will get only capital A. That is nothing but a constant straight line. You will get only the constant straight line. So this is the magnitude A. Magnitude A. Now this is A, which is having the magnitude A. Now what happens if A is greater than 0? A can be of any value from minus infinity to plus infinity, right? But A is equal to 0 is different. So that's why I have excluded that A is equal to 0. Now I am considering again two cases, if A greater than 0 and if A less than 0. Okay. Now those two are the two cases here. Now see here, A greater than 0 and A less than 0. So here A is equal to 0, you will get only the constant A. Okay. And what happens if we consider A greater than 0? A greater than 0 means obviously, no wait. So if we consider A greater than 0 means A is equal to 1, A is equal to 2. So all the values, you must choose all the values from 0 to infinity. And don't substitute, again, don't consider A is equal to 0. Why? Because we have already excluded that part. A is equal to 0 in case 1. That is a DC signal. And later on, we are considering if A greater than 1 means, now select A is equal to 1 here. Now again, you need to substitute T is equal to from minus infinity to 0. Now what you will get if you consider if A is greater than 1 and T is varying from minus infinity to, sorry, minus infinity to plus infinity. You must vary T from minus infinity to plus infinity, and by keeping this point, A must be greater than 1. This is a constant one. This is a constant value. What happens if we substitute T is equal to minus infinity? Now let us start our signal from T is equal to minus infinity onward. So X of T is equal to A multiplied by e power A, or you can take it as a 1 also. You can take it as 1. If A greater than 1 means obviously it is a positive. It is a positive. Remember, it is a positive value. If you are considering A greater than 1 means obviously A is a positive value. If you are considering A positive means obviously T here is negative. So plus into minus, you will get only minus. Now what is e power minus infinity?
0, sir.
E power minus infinity
0.
means?
0.
So obviously it is 0. 1 by e power infinity. 1 by, okay, e power minus infinity. Okay. So what you will get? X of T. X of T is obviously is equal to
0.
this one 0. So that should be starts from minus infinity. So that is why this point indicates that the signal starts from minus infinity and it is keep on increasing when we substitute. So obviously what happens if we are considering T is equal to plus infinity? What you will get? X of T is equal to, is my voice is visible? Sorry, is my voice is audible?
Sir.
Okay. See, if you are considering
Sir.
T, if you
Yes,
are
sir.
considering a case A greater than
Yes,
1,
sir.
okay. If we are considering the case A greater than 1,
sir.
and if we start our,
Yes, sir.
okay, if we start our graph from T is equal to minus infinity, obviously your graph is from 0 to, and it is keep on increasing up to T is equal to infinity. So you will get
Okay, sir.
signal which is defined from minus infinity to infinity. So that is why it is exponentially growing signal. So this is quite opposite to that of this one. Why? Because in this particular case, we are considering A is negative. A less than 1 means obviously A is a negative. A is negative. Again, if you are
Negative.
if you are going to start our x of t from negative values of time, that means at minus infinity, obviously you will get A multiplied by e power minus of, why? Because why I'm using minus of, already A is negative, t is also negative. So minus of minus means obviously you will get a infinity. So obviously x of t is equal to
Infinities.
plus infinity. Now your signal will start from infinity at t is equal to minus infinity, and it is keep on decreasing or decaying, okay, up to t is equal to plus infinity. So likewise, we are going to define the exponential signals. Is it clear? Is it clear? Clear to all?
Yes, sir.
Okay. Next, we are moving into the very important topic, that is problems based on the type of signals what you have studied so far. Okay. Now see here. Now see here. Evaluate the following. Evaluate the following. Okay. So let me solve one problem for you people. Okay, for your reference, and after that I will explain in a normal way. Okay, let me share my screen, whiteboard. Now see here. See what is the first problem?
So screen not visible, sir. White screen.
Screen not visible.
Yes, sir.
Okay, please wait. I am sharing my white screen, whiteboard. Is it visible to you?
Oh, okay, sir. White. Okay.
Okay. So here I am going to solve the problem number 1. Here, the problem number 1 is integral minus infinity to plus infinity delta of tau. You just carefully listen and watch also. Delta of tau into x of t minus tau. T minus tau multiplied by d tau. Okay. Evaluate the following. Simply you will get this problem in your university exam. Evaluate, that means you are asked to solve the problem and give the answer. Now tell me, is anyone give me any direction for solving this problem? Do you know what is delta of tau and what is x of t minus tau? Why? Because here you are having two functions. The first one is delta of tau is nothing but an impulse function which is multiplied by x of t minus tau, which is delayed input function. So here in the integral we are multiplying. Now see here, we are multiplying delta of tau and x of t minus tau. Obviously this x of t is a input function, but that is delayed input function which is delayed by capital tau units. Okay, and now this is tau, okay, which is also in terms of time domains, but here small t is used. That's why in the integral we are considering it as a tau instead of t. Okay, and you are asked to evaluate the following problem. So how do you evaluate the following problem? How do you proceed? Simple. First of all, try to remember the definitions of various signals what we have studied so far. Okay, here you don't have any information regarding x of t minus tau or original signal x of t. X of t minus tau can be obtained from x of t only. Please try to understand. This can be obtained only from x of t. If you know the information regarding the x of t, obviously it is very easy to obtain x of t minus tau. Why? Because if you delay this x of t by tau units, you will get x of t minus tau. Okay, so what is delta of tau? The basic unit impulse signal. Can anyone tell me the basic unit impulse signal definition? Delta of t is equal to, anyone? Please respond. Delta of
T is equal to dt is equal to 1, sir.
delta of t is equal to 1 for t is equal to 0. That means impulse signal is having amplitude only at t is equal to 0, and which is equal to 0 for t is not equal to 0. T is not equal to 0. Understand? Okay, so here I am going to multiply impulse signal with the unit impulse signal with the x of t, some function, but it is not defined. X of t, which is not defined, we don't bother about that one also. But here you are multiplying the x of t function with the impulse signal. So impulse signal, this is the basic definition of impulse signal. Delta of t is equal to 1 for t is equal to 0, and which is equal to 0 for t is not equal to 0. Now tell me, is it necessary to evaluate the function from minus infinity to plus infinity? Is it necessary? Is it necessary? No, it is not necessary. Why? Because this function, this particular function is defined only at a time t is equal to 0. So just forget about this minus infinity and plus infinity. Substitute tau is equal to 0. So at tau is equal to 0, delta of tau is equal to 1. At tau is equal to 0, delta of tau is equal to 1, and which is not equal to 0 means obviously that signal is 0. That means from minus infinity, you need not evaluate the function from minus infinity to plus infinity. Okay, so directly you can substitute delta of tau is equal to 1 at tau is equal to 0. That means what is the answer for this? If you substitute, or if you consider t is equal to 0 or tau is equal to 0, obviously x of there is no meaning for applying integration. You will get directly x of t minus tau at tau is equal to 0. Now what is the solution for this? The final answer is x of t. Hello everyone, please try to understand the solution for the problem we have discussed here. The first one is evaluate. Please mute yourself. Please mute. 224. 224. 18 series. Mute your mic. Okay, evaluate the following means obviously integral minus infinity to plus infinity delta of tau into x of t minus tau into d tau. So if you are asked to evaluate this function means you can substitute, first of all you can define the basic impulse signal definition delta of t is equal to 1 for t is equal to 0, and which is equal to 0 for t is not equal to 0. Later directly you can substitute tau is equal to 0 at this particular point. Obviously you will get delta of tau is equal to 1 multiplied by x of t minus 0. So what you will get finally? X of t. Similarly, next one also. So we shall stop at this after completing the second problem.
Okay, sir. We can stop now.
Okay, just one more problem. With that problem, we are going to complete this particular topic number 1, types of signals, okay, and the classification. Later we shall discuss in detail the classification of the signals. Now I am going to tell you the second problem. Please Tell me the solution for this time. You people, please tell me the solution for the problem what I have given you on the whiteboard. So here, delta of, sorry, integral minus infinity to, same, evaluate the following signal. Integral minus infinity to infinity. So delta of t minus 2. T minus 2 multiplied by sine pi t. Sine pi t into dt. See, in the earlier problem, we have used tau here. We are used tau here. Okay. Delta of tau multiplied by x of t minus tau. Why? Because already small t is there. Okay. If I again use small t in place of tau, you will get some confusion. So that is why I have represented that with another letter. But in this case, there is no problem at all. So delta of t minus small t minus 2 and multiplied by sine of pi into t into dt. Now please let me know how many of you have understand the concept. So what is the solution for this? Simple one-step answer. Okay, no need to struggle at all. This is only one-step answer. But the thing is, you need to understand the concept. So whenever any function is multiplied with the impulse function, obviously our problem will be simplified. You need not evaluate the function from minus infinity to plus infinity. Why? Because unit impulse signal is defined only at particular instant of time, and for all the remaining values of time that signal is not defined. Now tell me, what is it? What is the answer for this? Now see here, delta of t minus 2. Okay, there is a question here. No, it is not 0. So somebody has answered the question. Sorry, it is equal to 0. No, it is not equal to 0. Now I am going to explain why it is not equal to 0. So see here, delta of t minus 2 is equal to 1 for, now tell me at what value of time that's value is equal to 1. T is equal to
0.
No, t minus 2 is equal to 0. Please try to remember the basic definition. Here instead of t you are having t minus 2. So that is why you need to is my voice is clear? Is my voice is clear? Right. So okay, delta of t is equal to 1 for t is equal to 0. But here instead of t you are having t minus 2. So that is why I am equating t minus 2 to 0. Now what you will get? What you will get? T is equal to 2. So at this particular instant only, that's value is equal to 1, and for all the remaining values, so which is equal to 0, for t is not equal to 2. For t is not equal to 2. So that means you need not evaluate the entire function from minus infinity to plus infinity. Now please see here, what is the function value? Which is equal to sine pi t at t is equal to 2. Sine pi t at t is equal to 2. Now substitute t is equal to 2 there. What is sine 2 pi? Okay, I am mistaken. The value already somebody has given me the answer 0. What? So finally you will get 0 only. Right, 0. Okay, so good. Okay, so most of you have understand the concept. So I am wrong. So finally you will get the value is equal to 0 here. So understand? Do you understand what I am saying? The value. Evaluate the following question. Okay, clear? Okay, maybe sometimes I am also making some mistakes. You please rectify me. Okay. So with this content, I am going to stop this session. Okay, thank you all. Thank you very much for joining, and please stay. Sometimes 5 minutes or 10 minutes or 13 minutes or 15 minutes is not a matter. Okay, we should discuss the contents in brief. Why? Because the paid version is available with us. So there is no time limit. Okay, there is no time limit. Okay, thank you very much. Anyone is having any doubts? Anyone is having doubts? Or else I can
No,
end
sir.
the meeting. No doubts?
Yes, sir.
Okay, thank you. Thanks for patient listening, right?
Thanks.
Have a good day.
Thank you, sir.